All right, welcome to lesson 11. We're going to be using lines to think about situations, which just means doing word problems that include lines. The first question is your warm-up, and it says, what do you notice? What do you wonder? And they want you to see that the ladybug is moving to the right and that the ant is moving to the left in each one of these pictures. So the ant is moving towards the negative side of the graph and the ladybug is moving towards the positive side, because positive is always on the right side of your graph and negative is always on the left side. So you can write something to that effect to explain that question. We have two questions to go through, and they're pretty long, but we only have two, so it shouldn't be too bad. The first one is about bugs passing each other, but this time it's on a coordinate plane, and it says a different ant and ladybug are at a certain distance apart, and they start walking toward each other. The graph shows the ladybug's distance from its starting point over time, and the labeled point 2.510 indicates when the ant and the ladybug pass each other. So this is your x, this is your y. And then the first question wants you to write an equation representing the relationship between the ant's distance from the ladybug's starting point and the amount of time that has passed. So they're just wanting you to write the slope equation for this line. So the y equals mx plus b for the ant. If we were to write it for the ladybug, we could go and look at this graph and say that for 1 second, the ladybug travels 4 units, so the slope is 4/1, and it starts at 0 at the origin, so the ladybug's equation would just be y equals 4x plus 0, or y equals 4x. You don't have to do that, but that's just to show you what the equation is of the line that they've already drawn. But they want the line of the ant, so we're going to have to use the information they give us in order to make the equation. So if they're walking toward each other and the ladybug is going up this way towards the positive, that means that the ant is going somewhere towards the negative. We don't know where, but we know it's going to be going the opposite direction. So the ant slope must be negative, and then this was a typo. Instead of 4 centimeters per second, it should say the ant is walking 2 centimeters per second. So make sure that you fix that if your book also has that same typo. I checked in the teacher manual and it should be 2, not 4. Okay, so we know that the slope is -2. So when we go to y equals mx plus b, we can plug in a -2 for m. And then we can use these coordinate points, the 2.5 and the 10, and we can plug 2.5 into x. We don't know b. We're trying to solve for b, and we can plug in 10 for y. So then we can say, we can do 2 times 2.5, so 2 times 2.5, which is 5, -5, plus b equals 10, and then I just add 5 over. So then I get 15 equals b. And if you go to make it into its equation over here, you write y equals -2x plus 15. And that's your answer. And it wants you to draw a graph of the equation. So we could go and start at 15. So we can draw a point at 15 right here. And then the slope is -2. So you go down 2/1. And then you could go down 2/1, down 2/1. And that's where you would draw your other line, although that isn't intersecting, so that seems a little bit strange. And I'm going to check the answer key for you to see if that is right. Did I start it at 15, 14? I started at 15. Oh, you know what? The scales are funky. They're not 1-to-1. That's why that was not working. So it's like these are 1-to-1. So we could go down 1, but then we actually have to go over 1, here, here. Nope, that's still not lining up. Oh my goodness. These are supposed to cross though. So, down one, over one. What if we just do that? Down one, here. Okay, there. So that's how it should cross, like this. Ish. But that line should be somehow right over. It's not going to let me move it now. Just imagine this line crossing right through that point if it were drawn better. Okay, and then the reason why that's -2 is because it's going down, and then if you were to count the slope, you would go like this. And like that, and then that is 1 unit here and 2 units here, which is 2, which is the slope we wanted. Okay, last question. Elena and Jada were racing 100 meters on their bikes. Both racers started at the same time and rode at a constant speed. Here's a table that gives information about Jada's bike race. So the table is just Jada's information. And they want us to graph the relationship between distance and time for Jada's bike race. So you could put, we want to do it like this graph. So they put time on the X. So we'll write time here. And then this is distance here, distance. So then you just go and you can make a scale. So you can say like, okay, the seconds go maybe by 3, so it could go 3, 6, 9, 12, so on. And then we have to get up to 54. So maybe we go by 6s. We go 6, 12, 18, 24, 30, 36, 42, 48, 54. Okay, so then we can graph 6, 36. We go 6 up to 36, and then 9 up to 54. And there you can draw your line between those 2 points. Something like that. Okay, so there's our graph. And then number 2 says Elena traveled the entire race at a steady 6 meters per second on the same set of axes. Graph the relationship between distance and time for Elena. So if Elena is also traveling 6 meters per second, and you know that this is 6 because you can do 36 divided by 6, that's 6, as well as 54 divided by 9 is 6 as well. So they're going at the same speed, so you could just draw a line right on top of that line because Elena is going to be the same. And then who won the race? It would be a tie. All right, go do your practice problems.